Hello, this is Mr. Jackson, and today I want to talk about how to solve friction problems. Now, friction problems have a few more extra steps, and we got to be careful, but we're going to use the same process as we've been using all along in the problems that we've been building up, okay? So, here's our problem we'll start off with. A driver sees a deer and pushes on their brakes as hard as possible, but without sliding, so their tires are still rolling. If there's an 80 Newton force of drag, find the following for a car of 300 kilograms. So that's the mass of the car. So where do we start? Okay, we start by drawing a picture. Okay, we want to start finding the forces in our picture, and then we can start answering this following information list. Okay, so we need to find the number of forces, so our picture will be the best place to start. So we know we have 300 kilograms, so I want to find the weight. So 300 times 9.81 is 2,943. So the force of weight is 2,943 newtons. So that must also be the force normal acting up. Okay, it can't be any different. Okay, now you got to remember, if someone is hitting their brakes, they are not hitting their gas pedal. So in a braking situation or stopping situation, there is no forward force. But they did mention there is a drag of wind during this time because they were driving along. We have force of drag. Okay? But remember, they also have in our problem this mu, which means there is some stopping friction. So there must also be a force of friction from the road and the tires and the brakes. Okay? So that from the information is all I see. I don't see any other information I can enter. So I'm going to say there's 1, 2, 3, 4 forces that are in my idea. Okay? It says find the force normal. Well, hey, that was simple. In level cases, the normal is equal to the weight. So this is 2,943 newtons. Okay? Now it wants to know what type of friction is it. So they gave me a mu for both. They gave me the static one and the kinetic one. Okay, static means it's starting, but before I go and show you this and why I'm going to pick the one I'm going to, I want to give you a quick discussion about the two different kinds. Okay, in these problems you're going to have to decide on which one to use. Should I use static or the kinetic number? Okay, use the static number if you're starting to move or if an object is braking but it's still the tires are rolling forward. So when a bicycle or car are braking, you're going to use the mu s, the coefficient. This is called the coefficient of friction. Okay, mu. And so in these kind of cases, we're going to use the static. So the problem I just gave you just now, we're going to use the static number. Okay, we would use the kinetic one if we're moving, but it's because two surfaces are sliding against each other. Okay, we're assuming that the tires are still rolling, they're not sliding. Okay, and that was even mentioned in our problem. But if we're pushing a box and we know we can safely assume that surfaces are sliding on each other, then you'd use the mu or coefficient of kinetic friction. Okay, it's called the coefficient of friction. So it said that we're pushing as hard as possible, but without sliding. So we're going to use the static one today. So this one is not important. Okay? So we want to find this force of friction. Well, to find force of friction, I need mu and Fn. Well, I've got those numbers. I've got the mu, we're going to use 0.63. And Fn is 2,943 newtons. So 2,943 times 0.63. And so the friction we're going to encounter today is 1,854. 1,854 newtons. So 1,854 newtons. Okay? Well, then it asks, what's my net force? Well, I would think since there's no forward force, it would be the friction, but there was some drag mentioned, and drag also resists. So since these two arrows are in the same direction, I need to add those two forces. So the net force will be equal to 1854 plus the 80 newtons of drag. So 1854 plus 80 equals 1934. So 1934 newtons is the drag, the total net forces I'm experiencing. They just happen to be all frictional forces of some type. Then the question is, well, what is my acceleration? But in this case, it's really deceleration. And so we want to really find this acceleration. So we know F net equals ma, and I want to solve for the a. So I'm going to divide by the mass. So it's going to be the net force, 1934, divided by my mass, which was given as 300 kilograms. And so 1934 divided by 300, and I get a deceleration rate of 6.45 meters per second squared. Okay? Now, if that's the maximum I can push without sliding, then if you pushed a little less, you can get numbers less than this deceleration rate, but you can never get more than that. Because if you push any harder than that, you begin to slide, then you go over to kinetic friction, and that's going to change the whole problem. So this is the most you can push and decelerate at, then without actually turning into sliding, okay? So that's how you would solve a problem like that of a car going down the road. Let's do one more problem. Let's look at a person pulling a box across the floor. So they have a 50 kilogram box. They're pulling it across the floor. They're pulling with 325 newtons of force and is moving at a constant speed. Determine this following list of answers. Okay? So we're going to find these answers. So where do we start? Like we did last time, we're going to draw our picture. So here we have a box on the floor. Okay? It weighs 50 kilograms. Okay? They are pulling it with 325 newtons of force. So you can call it tension or applied, whatever you want, is 325 newtons. Okay? Here's the person right here. So we're pulling, and we can add to our thing. We know we have a force of weight, and we know we have a force normal that's being pushed back up. And we know since they're sliding together, there's going to be friction. They didn't mention any drag, and we're not going probably very fast to worry about air drag. And so if I look at that, I don't see any other things I can add to it, so I'm going to say that there are also 4 forces in this problem. They want to know the normal force. Well, I told you already that the force of weight and the force normal in all level situations are the same. So let's find our force of weight. Our force of weight is 50 times 9.81, and we get 490.5. I want 3 numbers, so we'll just say it's 491. Okay? And so we know that this is going to be 491 newtons. Okay, it says that. Now, what's the force of friction? Well, force of friction, we know from our equation we've been given, is mu times Fn. But I don't have mu. It hasn't been given to us up here. So how do I find the force of friction? Well, there's another way. You got key terms. Here it said constant speed. What does constant speed mean? It means that as they're pulling it, it's moving at a constant speed. There is no acceleration. Okay? So if acceleration is 0, then F net is 0. Okay? There's no acceleration. So that means that the force applied is equal to the force of friction. This is a key idea you need to remember whenever there is considered to be constant speed. So whenever you have constant speed mentioned, you know that the forward force and the reverse force are the same, so that they cancel out. So this has to also be 325 newtons. Okay? So I actually know it because of these key terms. Okay? Now, so it says, what's the net force? Well, the net force is 0. Okay? And so here's what we're going to do. We need now figure out what type of friction it is. If I want to find the value of the coefficient of friction or the mu number, then I need to be careful what type of friction am I dealing with. This time the surfaces are sliding across each other. So we are dealing with solving for a mu of K, a coefficient of friction that is kinetic. That's the one we're solving for this time. Okay? So we're going to solve for mu. How do I find mu? Well, here's my equation. Force of friction is mu Fn. If I know the force of friction and I know the force normal, I can find the mu number. So I just simply divide the force normal, so mu is going to be the force of friction divided by the force normal. And do I know the force of friction? Yes. Right here, 325. Because we are at constant speed. Okay? And then the force normal is the force of acting upward, which is 491. And I just have to divide those two. And remember, we should get numbers that are always less than 1. So 325 divided by 491 is 0.662. Now, I want to talk about something here. Newtons divided by newtons is nothing. So there is no units for the mu. Mu is one of the few numbers in physics that are called unitless because they're just a number rating. So mu has no units with it. Okay? So that's very important to remember. And it's one of about 3 or 4 numbers that we run across that have no units after the number. Okay? So that is our final coefficient of friction answer. So that's how you would solve it for a sliding situation, remembering that the sliding then would be a type of friction of kinetic. Okay? So that's how you solve those two kinds of problems, rolling ones and sliding ones. So there you go. And I hope it helps you.